Today will be the last normal class.
Normal class?
Yes. The rest will be for softwares, for presentations, for revisions.
Last class, maybe check and speak.
No, not the last class. Do you know the reason why? I don't just want us to come here, have masters, then all I'll be teaching you is theory. So I want to teach you a software, though it's not part of my work. But if you want to learn it outside, you pay heavily. But since I know it, so I will teach you how to use it. So it might be useful for you later on, especially when you are dealing with, for those who want to work in places like GSK. Because I once applied to that place before, you remember? I once applied to that place before.
Which software is it?
No, it's just design of experiments for formulation and the rest like that. We call it DOE. DOE. I know some of you, maybe you are familiar with it, but you can just brush your knowledge about it because I've been using it for the past 7 years. So I know the in and outs of that software. So I will teach you how to use it, both in academic work and in industrial work. Actually, I wanted to teach you how to use techno-economic modeling too, but the software is expensive. It's around £9,000. So I'm planning to already put it forward to see if maybe next class, maybe next year, I can put it forward to the school. So we can have the student version or academic version, which is 3,000. So we teach those maybe from the other next year. Our topic is hazard and operability study in separation process. Please listen and listen well, because this topic is very important. This is what people in industry, people with who are certified, what do they call them? Certified, call them something, I can't remember. Safety officers. These are the things they teach them. So, and I will try as much as possible to be more practical. And we have different practical, examples to that. Now, what is hazard in relation to separation process? Did you do anything like hazard and operability in your masters here?
Sorry?
Any module that relates to hazard here? No. Okay, that's good. So, but for hazard in relation to separation process, so we tailor hazard and operability study, and we will relate it to what? We relate it to separation process. Please listen and listen well. The other time, I think I was trying to tell you different area you can venture in, or you can be a specialist in. This is another part, safety. So if you are here in UK, you can actually take different safety certification. And with that, you can apply anywhere as safety officer. Exactly. So that is one aspect you can specialize in. So an hazard refers to what? Any situation or condition within the process that could lead to an unintended release of either energy, material, posing risk to personnel, equipment, and environment or product integrity. So any situation or any condition or any material or anything that could lead to that could pose risk either to people working in a particular place, so that is called hazard. Now, in separation process, we have different form of hazard because we are tailoring this towards the separation process. Let's give an example of our distillation process. One of the potential hazard in distillation process is overpressurization in the column. So when there is elevated pressure inside our distillation column, we can have what we call a blow. We call it, is it blow up or blow out? I can't remember. It also happens in a refinery also. So in which, when there is a buildup of pressure, what happens? Everything is a boom. And that is one form of hazard. especially in distillation process. So now, in your design project, you need to factor that one in also. What are the potential hazards? If you are working with sedimentation, one of the hazards is the sludge buildup, and we can actually lead to blockage of equipment. So factor in the hazard as it relates to your what? As it relates to your project. And that is where environmental and sustainability come in. You remember that part? So the last part that has to do with environmental and sustainability, you can put hazard here and other things. Exactly. So now that's sedimentation. So in filtration process, one of the potential hazards in filtration process is high pressure, which can actually cause filter to burst or release hazardous chemicals. You remember in filtration process are pressure driven, right? But when you have elevated pressure, it can actually break or rupture your filter. And once your filter is ruptured, it could actually lead to maybe if someone is working there, maybe there will be spillage and a lot of things like that. And if you are dealing with hazardous chemicals, it means there will be release of hazardous chemical into your system or into the production line. So that is filtration. In centrifugation, one of the potential hazard is rotor imbalance. You know, centrifugation work like this. You understand? But when there is imbalance, it's more or less like it's more or less like a grinding machine. The grinder you use inside maybe to grind things inside your kitchen. If you have a grinder that is not balanced, what will happen? Everything will be what? Shaky. The same thing applicable to centrifugation. One of the potential hazard in centrifugation is rotor imbalance. Then, in membrane separation, one of the potential hazard is membrane rupture. So membrane can rupture. So that's one thing about membrane separation. Which other one? Can someone give me another example of separation process and potential hazard that you think of? In absorption process, separation process also. One of the potential hazard is flooding. Have you heard of flooding before in absorption?
Yeah.
We have flooding, priming, coning, entrainment. Remember?
Yeah.
So in absorption process. So those are potential hazards too, because in a situation whereby you have flooding and the rest like that, it can actually lead to other unplanned events. And those are the what? Potential hazard. So for any process design or product design, especially in separation process, you need to look into potential hazard. So in biochemical engineering next week, we'll be dealing with biohazard and biosafety. That's very important because that is one of the most difficult aspects of biochemical engineering. So we deal with hazard there too. So, but in advanced separation process, we are more concerned about the hazard as it relates to separation process. Now, that is hazard. Then what is operability? Operability is the ability of a separation unit to function effectively. If we say Krish, right? Krish, the operability of Krish is the what? Is our ability to function effectively. Exactly. So now that's the difference between hazard and operability. Hazard has to do with the potential risk, right? While operability is the ability to function effectively. So operability addresses condition where the process deviates from its intended design, leading to inefficiency or inability to achieve desired outcome without posing immediate risk. Now, what operability does is that it checks your separation process or separation unit and see is there any deviation You understand? From the operation of that unit. Take for instance, in microwave separation, we use microwave technologies for separation process too. That's the advanced stage. That's another separation process. I use microwave in my PhD. In microwave technology, we can use microwave technology for separation process also, most especially in mining industry, in food, and the rest like that. But one of the issue that microwave technology, one of the potential hazard is that temperature in a microwave is an uncontrollable factor. And that is the reason why in microwave, even your normal microwave, you have power and you have temperature. They are not the same. You can set power to a particular point, but you cannot set temperature. You will set temperature to 70 degrees. Before you finish that process, it has jumped to like 80 degrees or 70 or maybe 90 degrees or even 100 degrees. I think there's a phenomenon we call, I've forgotten that phenomenon. So what happens is that even when you set your temperature to a particular set point, you will not meet it there when you go out and come back. It will have readjusted itself. And that is, we call it fluctuation, noise factor. That's the reason why temperature is a noise factor in microwave technology. So what you are saying in essence is that now, any deviation from the normal operation of a particular separation unit affect the operability. And when operability is being affected, there is no hazard though. But anything that affects the operability of our unit operation or separation process can actually lead to what? Hazard. Now, let's look at an example. In distillation process, ineffective separation due to insufficient reflux can cause off-specification products. And when there is recurrence of off-specification products and there is a build-up of that scenario, what happens is that it's more or less like you are preparing for hazard. An example is when you have a car, and let's say today you started having maybe hearing different sound in your car. The car is still moving, right? But the operability of that car is what? Is being affected. There is a deviation in the operation of that car. Even though at that point there is no hazard, right? But it can actually cause hazard. Take for instance in your car, let's assume there is a tear and wear, maybe on the tire. What happens? That tear and wear can actually affect the operability and eventually lead to what? Hazard. So operability and hazard, they are what? They work hand in hand. An example is this: you are in class, right? Mukunda, you are in class, right? You won't fail. But let's say in class, you started talking. So your reason for being here is just to sit down and listen to me, right? But the operability, there is a deviation in your what? In your design as a student. So there is a potential hazard. And what is the potential hazard? Failure. Do you understand? So you now see the difference between operability and hazard now. Now, in sedimentation process, for example, poor settling due to incorrect chemical dosing resulting in high turbidity in the output. This is one operability issue also. I'm explaining this because you need to factor that in your design also, especially under environmental and sustainability. Exactly. Now, infiltration, another operability problem is that we can have when there is a reduced flow due to filter clogging or disruption downstream operation. That is an operability problem, and it can actually lead to a potential hazard. It's more or less like, it's very simple. It's more or less like there's a particular word they always say: prevention is better than cure. You understand? And prevention is better than cure, or centered on the operability issue, right? When you prevent something, not that you have a problem already, but you are preventing it for you not to have that problem. right? So that is operability study. Now, so hazard in separation process often stem from operability issue. This is where I'm going. And hazard will not just happen, right? But hazard happen because there is an operability issue. And you as a chemical engineer or you as a maintenance officer or safety officer, one thing you should be more concerned about is operability issue in your operation. And that is what we call preventive maintenance. That is where preventive maintenance comes in. Such that, let's say today you discover, oh, there is one of the bolts is what? Is loose. You understand what happened? You tighten it again. Even though that loosened bolt will not cause any problem, right? But the more you allow it to grow, what happens? It can lead to an hazard. So now what I say in essence is that hazard in separation process often stems from operability issue. That is, ability of a unit to function effectively. Someone will ask me, what is the meaning of this? Why am I teaching you this? So I'm opening up your mind now that when you go for interview and they're asking you question, even if you don't know, you don't have experience, you can actually use your theoretical knowledge to explain. I've done that before. Oh, we have an issue in this company and it's a maintenance issue, blah, 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 blah. As a maintenance officer or a safety officer, how can you be of help? Then you start blowing grammar. No, actually, the first thing we need to take into consideration is to understand the interrelationship between hazard and operability. And hazard will not just happen, but most hazard take place because there's an operability issue. So as a safety officer, one thing I will take into consideration is the operability issue in our operation. What is operability issue? I will check, maybe even before hazard occur, I will check if there are different, There are different maintenance we need to carry out in order for us not to have operability issue. And they will start looking at it. What is operability issue? What is this? You never know it's for your master's or whatever. So you need all this understanding, especially if you are working in safety and maintenance unit. So now, definition of hazard and operability. So what is different between operability and hazard? So hazard is any operation that could possibly cause a catastrophic release of poison, flammable, or explosive chemicals, or any action that could result in injury to what? To personnel. While operability is any operation inside the design envelope that will cause a shutdown that could possibly lead to a violation of environmental, health, safety regulation, or negatively impact profitability. Wait. Most of those things we buy, do you know the reason why they always have a manual? They will tell you, don't expose this to sunlight. So most times, operability has to do with something that is embedded in our design. So by the time you are designing a sedimentation unit, you need to tell me what are the potential operability issues that will happen in your design. And how can you what? How can you prevent that issue from happening? So for us to prevent any hazard from happening, the first thing we need to take into consideration is to what? Is to attack the operability issue first. And that is where prevention is better than cure. That is where it comes in. When somebody give you a gun, for example, they will tell you, don't always put that, if you're in military. I've done paramilitary before, that's why. So they will tell you that, okay, you can only, except if there is war or there is an issue, you need to keep that, what's the name of this thing? That magazine. You need to keep it in your this thing. So when there is an issue, that's an operability issue. If not, there will be accidental discharge. And when you are handling it, you don't put your hand on the trigger. Except you are in danger. You can only put your hand on the trigger when you have red clothes on that what's the name? On that on that gun. So anybody that sees you and see red clothes, they know that this one is danger on its own. Do you understand what I'm saying? That is in a military side. In what's the name? If you buy what's the name of this? Certain drug, they will tell you, certain medicine, they will tell you, don't take this drug, don't take this medicine with citrus. So what they are preventing is operability issue. In separation process too, when you have different units, they will always tell you, they will always give you specification of the ranges you can go, the range of temperature, the range of pressure you can go. What they are trying to prevent is operability issue. So do you understand now? So operability issue has to do with, it starts from the design, even before hazard occur. So from the time of procurement, you already know this operability issue. This is something I need to do. This is something I need to. This is I mustn't touch this. If I touch this, it will cause explosion. So that is operability issue that needs to take into consideration. Hazop study. I think you are familiar with this. Hazop study is an examination procedure. The purpose is to identify all possible deviation from the way in which a design is expected to work and to identify all the hazards associated with this deviation. You have a manual, right? And the manual tells you, don't exceed this what? Temperature. Or in road safety, they will tell you, don't exceed, if you're on the highway, I think the highest speed is, I think 70, is it 70?
Yeah. Or 70 miles, yeah.
Is it 70 kilometers per hour? I can't remember.
70 miles.
70 miles. But if it is the normal road, it's 60, right?
No.
It's not 60? No, except if they put 40, 20, at least 60.
Yeah.
So that one is just like they are trying to tell you that, okay, this is the what? This is a normal allowable range. But they will still tell you that, okay, if you go beyond this, this is what will happen. That is Hazop study. So that is where Hazop study starts from. So when deviation arises that result in hazard, action are generated that require design engineers to review and suggest solution to remove the hazard or to reduce its risk to an acceptable level. So what we are saying in essence is that, let's assume that, okay, you have a microwave that you produce and you discover that, there has been an explosion. At least with those people, I think there is an issue now with an air fryer. You need to be very careful. I think it's causing explosion everywhere now. Air fryer. Yes. So you need to be very careful. Don't just leave it there. And maybe go to the toilet and say, I'm coming back. Maybe the whole house will have been burnt down. You don't have any house here. Huh? So, what am I saying in essence is that there has been different reports of what? Of air fryer blowing up and the rest like that. So what design engineer will do is that, okay, what really happened? Is there any deviation? Now, maybe the normal temperature you should use is 160. So they discovered that, okay, what happened? What caused this fire outbreak? Everybody using 200 degrees C above, they are the one that experienced this. And they may actually put something there, maybe a knock, that will show that, once you start adjusting it, you say, and that should show you that, you're already what? Going off balance. You're already deviating from the normal range. So that is the first thing. So, systematic technique to identify potential hazard or operating problem, that is Hazop study. So it involves a multidisciplinary teams who methodically brainstorm on the plant's design. Thank God. So a qualitative techniques based on guide words. Please underline that one. Guide words is used to help provoke thought about the way deviation from the intended operating condition can lead to hazardous situation or operability problem. Don't worry, you understand this. Now, benefits. The circumstances when Hazop studies are likely to produce benefit is when doing a design or installation of any new plant or process, a major modification to an existing one. Susaya, what happened? The salary enter? You're most cheerful today. Or you are watching movie, eh? Don't tell me that is the reason why you are laughing.
No.
Okay, don't worry. I hope to see you laugh during the exam. So now, what you are saying in essence is that we have different So we can use Hazop study, or we can conduct Hazop study, one, during the design or installation of any new plants. Like now, we are designing different equipment now, right? So this is when you can use Hazop study. So, under your environmental and sustainability, you will add Hazop study to it, right? So don't worry, I will tell you how to do it. It's very simple. So now, another time you can use Hazop study is when there are unique hazards, such as environmental hazard and quality or cost issue associated with an operation. And another time is following a major incident involving fire, explosion, or toxic release pattern. So you conduct Hazop study again when there is accidents. You understand? Okay, something has happened. Maybe someone in the lab or acid or whatever happened. So we can conduct Hazop study. We can identify what are the potential hazard or the issue that leads to that. Maybe in the process of going, we discover that maybe the step is steep. So by so doing, you can actually prevent the reoccurrence, right? So that's another time. So during installation or design of an equipment, you can conduct Hazop study. Then secondly, when there is a major incident or accident, then you can conduct it. And lastly, to justify why a particular code of practice, guidance note, or industry code is not to be followed. So we can actually use that one also as the reason for conducting Hazop study. Now, so potential hazard and operability problem. So because of the high profile of production plant accident, emphasis is often placed upon the identification of hazard to the neglect of potential operability problem. Yet it is in the later area that the benefits of Hazop study are usually the greatest. So Hazop study is useful most of the time if we are able to identify operability problem. It's more or less like, okay, you know that if I do this, this is what will happen. Do you understand? It has not happened, right? If I do this, this is what will happen. If I don't read my book, this is what will happen. If I delay in applying for my visa, I will overstay. So that's operability problem. Okay, if I switch on this knot, what will happen? The pressure will increase. And if the pressure will increase, maybe my filtration system, the filter will break. And if the filter breaks, what happens? It's possible we have a release of toxic materials and the rest like that. And maybe cost issue also. So that is that about that. So when should a Hazop be held? I think I mentioned that. Then now we have different terminologies. Please, this one is very important. If you are a safety officer, all this you need to know. Not many people know this. But if you're a safety officer, all this you need to know. So the first terminology is the cause. So the cause is the reason why the deviation could occur. More causes can be identified for one deviation. The second one is the comment. So any remark to be given to a recommendation or which in another way show up during the Hazop section. That's it. That is a comment. Then we have something we call consequence. That's another terminology. For consequence is the result of the deviations. The result of the deviation in case it occur. So if the deviation occur and maybe we didn't take cognizance of it, then that's what we call the consequence. Now we have deviation. What is deviation? A way in which the process condition may depart from its intention. Then what is intention or design intent? So, hello, these are the things you can use maybe to design your operability or Hazop study for your design. So all this is very important. You can include what is in my notes inside. Don't worry. You can steal it. Don't worry. So we have what we call intention. Okay, guide words or keywords is a short word to create the imagination of the deviation and so on and so forth. So we have different examples later on this. Then we have parameters. That's the relevant parameters for the condition of the process, like temperature and so on and so forth. We have study line or note, a specific location in the process in which a deviation occurs. So if the deviation occurs maybe in social separation units, we call it the notes. They can ask what? Okay, you I think you told us that there's an issue of outbreak. Can you show me the notes? The note is that place where I was. The accident occur. Then recommendation, activities identified during the Hazop study for follow-up. So safeguard. Safety that help to reduce the occurrence is what we call safeguard. The action, where a credible cause results in a negative consequence, it must be decided whether some action should be taken. So that is Hazop terminology. Now, in any Hazop study, these are the major contents. Please, all this you know that you will not what's the name? You may not appreciate it now until you get into this. I think, do you have any safety officer here? Mukunda? I think you've done something on this before? Safety officer?
I don't did HSC course.
HSC. Did you do anything like Hazop study?
Yeah.
I think Jyoti, did you do anything like this?
I used to be safety officer.
Okay, did you do anything like Hazop study?
Yes, we used to do a Hazop study, material safety and design safety.
She has a certificate.
No.
You have the certification too?
No,
Messiah? I think you understand it more because you've done this before. But I'm just giving you a generic Hazop study. So there are different Hazop study specific for different issues. Like for example, we do different examples now in this class, and maybe we'll do it together and you see how we can use Hazop study in separation units, right? I think it came out last year. I don't know if it will come out this year. So now, the first one is planning. Second one is team, report, track action, and closeout. These are different stages. Now, sequence for conducting Hazop study. This is just a sequence. You don't need to cram it. Divide a section, select a line, analysis, recording, reevaluate. Then how to perform Hazop on a provided example. The first one is a prepare for the Hazop. Don't worry, we'll do one or two examples on this. Include process engineer, safety specialists, and so on and so forth. Then collect PID or process diagram, equipment, data sheet, and so on and so forth. I think it's 1 hour already. I give you 5 minutes.
Break?
Yeah, break.
Thank you.
Listen, I only ask you to design a process, Jyoti. I only ask you to design a project in which a particular separation unit is being used.
Okay.
Take for instance, let me re-explain. Please listen. So look at this. What's wrong with you? Now look at this cyclone, for example. You have been tasked to design an industrial scale air cleaning system for a cement manufacturing plant.
He's already
Blah blah. So this is a process. You understand? But your calculation will be the calculation I want to see, your design calculation. I only want to see calculation based on that separation unit, the one we do in class.
Like mass balance and
Exactly. The mass balance will be based on that separation units.
okay, cycle.
For example, for design of centrifugal sedimentation, so the calculation will be based on centrifugal sedimentation. But don't forget, a pump will be there, maybe pumping into this and the rest like that. There may be a storage unit. That one I don't need the calculation. So I only need the calculation for everything that is entering that separation unit. So it's a process I want you to design, but you are trying to amplify that particular separation unit.
Okay.
Not just that you just give me this and say, okay, I design this. No. What are other processes involved? Because they will challenge you. You know, you are presenting this. Huh? I'll be looking at you and be smiling. Huh? Because professors will come, different people will come. Please listen and listen well. I ask you to design a process, not just the units, but the design calculation will be the design calculation for that unit alone. I think I'm clear.
And we can use this slide.
You can use my slide, you can use anything, just steal everything. You can use my slide. But don't copy and paste. Don't plagiarize. Don't use AI, I know, because I use AI very well, so I know you use it. So if you use it, I know, right? But you can only use AI maybe to gain idea, you understand? But not that whatever it gives you, just copy it and do boom. It's zero.
And what about second topic, design of
What's that?
what about second topic?
Huh?
What about second topic, like design of a second?
I mentioned that now. It's same.
Same.
Use the sentence.
Then for design of reverse osmosis unit, I think we had that with separation 2. If you don't understand, if you have anybody there, they can teach you. So we did something relating to this, but it's very simple. I thought to reverse osmosis, we have arrow. You can use that multi-stage whatever calculation for it. You see now, you can use multi-stage calculation for this, but this is the most simplest for group 2. Group 3. This is the simplest. So let's continue. You get what I mean? I think I'm clear on this now, right?
Yeah.
So now,
So when is the presentation like?
I will tell you. You will defend in group, right? So what you can do is this. If you are 5 in a group, ask one student to maybe to undo introduction, problem statement, or whatever it is. Then another person to undo maybe design calculation, parameter, whatever. Then another person to undo maybe 2 people, 2 or 3 safe, depending on how many you are in your group. 2 or 3 people to undo the flow diagram, PID diagram, block diagram. Very important. 2 people. Because one single person cannot do it. But if you have someone like Aris, Aris alone can undo that. You have someone like Malik.
I think if I have handled then
We have someone like Mukunda. So But let's continue, please.
यूनिवर्सिटी में है वो बनाया हुआ है यूनिवर्सिटी में है वो
Okay, let's continue. Hello? Let's continue. I think it's clear now for each group, right? So let's continue. So, but time is going. If you have not been doing anything, please. There won't be any extension. There won't be any what? Extension. So now, how to conduct or how to perform? Please listen. It's okay. You can finish your meeting after, maybe group meetings.
Yeah, sorry.
So how to perform Hazop on a provided example? The first one is a prepare for the Hazop, so on and so forth. But the second one is divide the system into study nodes. So that is each process is divided into smaller parts or nodes to analyze them systematically. Then centrifugation, like rotor and so on and so forth. Don't worry, we have an example here. So apply guard words. These are different guard words. So identify safeguards. So okay. And the last one is recommend actions. Then document finding and so on and so forth. Follow up implementation. Then now, let's look at this. A chemical processing plant uses a reactor to produce a product by mixing two reactants A and B. This is, what's the name? It's a exam. Possible exam question. So a chemical processing plant uses, see now, the class is quiet now. Uses a reactor to produce a product by mixing two reactants A and B. The plant has reported an incident where the reactor temperature rose significantly above the design limit, leading to an emergency shutdown. So this one, Hazop study for this one is after an incident occurred, right? So during the investigation, it was discovered that the temperature control system failed. And there was no adequate backup system in place. This posed a risk of thermal runaway reactions, potentially causing an explosion. So you are being asked to conduct hazard and operability study on the reactor operation to identify potential hazards and suggest suitable solutions. 1. Conduct a Hazop analysis for the following parameters: temperature, flow, and pressure. 2. Propose one preventive measure and one mitigative measure for the identified hazard. One question, but I don't know if it will come out or not. Now, the first question says we should conduct Hazop analysis. But before we do that, let's analyze that question. Can someone reread this one and tell me what you understand by this scenario? Who's this guy? Oh, he's not here. Ah, you. It's you I'm looking for. Tanvi. I know you work in industry. So can you verify this one for us?
I was in a quality. Totally different.
Imagine. Now you are denying your role. I must meet with your line manager. So, who will read and explain this to us? Analyze this question for us.
Okay.
Explain, just tell me what you understand from this question. He asked me to mumble. Ali?
Malik.
Can you explain this for us?
Malik.
Yeah. Malik, can you explain this for us? And then we do the Hazop study, analysis. What do you understand by this problem? From this problem, can you tell us what happened?
So it is like what you mentioned, like micro oven, the principle what you mentioned there.
Is there any microwave?
Not here, not here. Like in the class you mentioned like micro and temperature.
Yes. Okay. You know, you've been talking.
Yeah, they said that in the industry, in a plant, like there was some temperature control and the system failed.
What was the incident that happened?
The temperature control system failed.
There was no backup.
And there was no backup with the system.
So what happened here?
There was no preventive maintenance.
Temperature control system failed.
Yeah.
Yes.
So we were unable to control the temperature. You know that's dangerous.
Yeah, that's very dangerous.
And what was the cause of that temperature control malfunction?
There was no backup system in the place, and it caused some thermal reactions or something.
The
And this
operation
was
got
a-
shut down.
I didn't understand you. All of you are just Ali?
Yes.
So we have identified the problem. What was the cause?
Leading to an emergency shutdown.
That was happened.
Yes.
Then what was the cause of that emergency shutdown?
Increasing the
The
reaction
temperature.
rate
Temperature. Okay.
to explosion.
Okay. So you have been asked to conduct hazard and operability study on the reactor operation. So now we are asked to conduct an Hazop analysis on these parameters: temperature, flow, and what? Pressure. Okay, now this is the Hazop analysis on the 3 flow. Don't forget these are the components. Please listen. If I give you this kind of question, this is how to answer it. Deviation. What happened to temperature? Please listen. Is there any issue? Please, I will scatter you. Malini, she's gentle today. Mukunda and Malik, all these 3 people at the back. Please don't disturb my class. No problem. Please remind me. Let someone to remind me of this. Now, what was the deviation with temperature?
High temperature.
High temperature. What was the possible cause? Failure of temperature. Consequence is what? Thermal runaway. See, it's simple. So it's from that question. The only thing is just you need this.
Hazop analysis.
Then what was the recommendation from your own end? You can install redundant temperature control system. What is the meaning of this? You have one temperature control system, there is a failure. Then we can have a backup temperature control system. So that solution is from you now. Now, from that system, in terms of flow, what happened to the flow? Low or none. Then clogging. What happens to the possible cause? Clogging in reactant feed line. And what will happen because of the flow? Maybe improper mixing or incomplete reaction. Then this one can be solved by what? Regular maintenance of the feed line. Then if it is pressure is high, blockage, possible blockage in outlet or cooling failure. You can give me another thing. It's not compulsory. You give me the same thing. Right? In as much as it makes sense. But once you know that you are giving me something new, then explain it for me. Don't just give me the point. Then what is the consequence? Rupture, overpressurization, and then hard pressure reliever. That is the recommendation. And if I like, I can give you all this and just ask you to give me a recommendation. Maybe I just give two marks. I'm not sure if it will come out. Now, the second question says, propose one preventive measure and one mitigative measure for the identified hazard. Preventive measure. Very simple. It's just like we are repeating it. Install a redundant or independent temperature control system to ensure continuous control, right? Even if one fails, you can actually have a backup on the redundant one. Then mitigating effect measure, install a pressure relief and design a safe venting system to release excess pressure and prevent explosions during emergencies. And what is the justification for this? This measure will address both the likelihood or the severity of the hazard, and it will ensure reactor operates safely and reliably under all conditions. That's it about that question. The second question. A water treatment plant with a chlorine dosing system to disinfect water. During an operational review, it was found that excessive chlorine was occasionally being dosed into the water due to pump calibration errors, posing risk to downstream users. The Hazop study is required to analyze the system and propose solution to prevent such occurrence. Now, perform hazard analysis for these parameters: flow, concentration, and pressure. Then the same question. So the only thing that will happen is that we can have different scenarios, but it's the same thing. So if the flow is high, just as the one we have the other time, pump over calibration, excessive chlorine dosage, all those things, they are inside the question, right? Then recommendation is from you now. You can implement. So all this, you can actually get all this inside the question, right? The only thing you are adding to it is what? Is a recommendation. It's very simple. So, preventing measure. You can actually use automated chlorine dosing system equipped with flow control and so on and so forth. The mitigative effect and measure. Add dechlorination stations downstream to neutralize excess what? Excess chlorine. And then justification, preventive measure and so on and so forth. So that's it about that. Can someone do this for us? Can someone do this for us? Conduct Hazop analysis for the following parameters. A petrochemical, Harris,
Yeah.
read for us.
A petrochemical plant operates
Ali, you solve it.
a distillation column to separate a mixture of hydrocarbons into light and heavy fractions.
Okay.
During routine operations, the plant experienced an unexpected increase in pressure within the distillation column.
Okay.
This led to the activation of emergency pressure relief system, which vented valuable hydrocarbons and posed a safety risk.
Okay.
A Hazop study is required to analyze the process and proper measures to prevent such incidents. Now, conduct a Hazop analysis for following parameters: pressure, temperature, and level, and propose one preventive measure and one mitigative measure for the identified hazard.
Okay.
Solve it, Ali.
Ali? Ali?
Yes.
It's your turn.
So in this scenario, the pressure went too high, due to which the emergency pressure relief system activates.
Okay.
So temperature also gets high and level.
I'm listening. Ma, Malini,
Yes.
what's the solution? Conduct Hazop study.
Solution for how to conduct Hazop study?
For this problem. I'm coming. So that's the last problem. And if you like, is that what I say? I say if you like, just check for me. What's the solution to this? What am I saying? It's like, if you only want, conduct the Hazop analysis on pressure, temperature, and level for this distillation problem.
For the pressure, the deviation can be high for the pressure,
Yeah.
and then the possible risk is the possible solution is to put like pressure relief valves.
Good.
Then for the temperature, I feel like we can use redundant temperature.
And we want to say.
Okay, it still makes sense. I'm listening. What about level?
For the level
Level indicators.
Level indicators?
Yeah.
Okay.
Yeah.
Okay, that makes sense, right? So pressure, you're right. Everything's I, right? Block reflux, the same thing. But the only issue is the recommendation. Hello, please listen, please. The only thing is the recommendation, right? For the recommendation, install high pressure alarm. So that when the pressure is high, it will start doing why. Then for temperature, you can have automatic temperature controller or AI, artificial intelligence controller. Then for the level, you can include level sensors. I think we have that in many companies. You can have level sensors with automated control valve. Then, last but not the least, preventive measure, the same thing. Install advanced process control system to continuously monitor and optimize pressure, temperature, and level within the column. Then the same thing, mitigative effect, add a vent gas, recovery station, recovery system to capture and safely store hydrocarbon in the event of prior relief. And that's that about that. Any question? Is there any question? Now, group 1, stay here. Group 2, stay here. Group 3, stay here. So I want to know what you have done so far, if there's any problem. And all the meetings you want to do before, it's time for you to do it now. Yeah.
I like the template you got.
Okay, come.
You gave chance for him. So it's in take the chance. He's not.
I don't want.
Yeah, he's like.
You go.
You group 2? You group 2?
Priyanka.
Yes. Group 2.
Yes.
Let's go for a problem.
Yeah, I'm going.
So please discuss for 15 minutes. I'll come and meet you on each group.
Yes.
Which group is this? If anyone.
the second year.
Go and meet your group early, Pami.
Different processes. Osmosis. Some other process like sedimentation. We should include that. That's what he was mentioning.
And maybe you discuss what you have done each.
Yeah. Not only that, other things.